Hi there, this is video U 4.2 on the sine law. So this is the introduction to the sine law. If you watched the last video and you made it through the end, good job. I still don't know how long it was, but I know it was really long because it took an awful long time to do all those calculations using Pythagorean's theorem. Doable, but long. Sine law actually is really sweet. It's way shorter than that. Anyway, let's get to it. So just so you know, okay, I'm going to say it on video. I don't like our textbook. I think I just don't like your textbook. So what they do is they split the sine law into two distinct sections. One that deals with acute triangles, which are angles that have all angles less than 90. And another complete chapter that deals with obtuse triangles, which are ones that have an angle over 90 degrees. And I don't like that. I'm just going to teach you how to do the sine law. And then at the end, I'm going to say, yeah, well, this is the one change you have to watch for if the angle might be over 90 degrees, rather than teach it as a completely separate topic. So that being said, let's get at it. A little bit of stuff to remind you of. Capital letters always represent, oh, you know what? You could stop the video right now and do this on your own. Go ahead. I'm going to trust you did. All right, capital letters represent angles and are measured in degrees. Remember that some days you're having a bad day. It's like, is that a side or is that an angle? Well, if it's got the little degree thingy on it, like that, that's an angle. Can't be a side. The lower, so A, B, and C refer to the angles. The lowercase letters represent lengths of sides. And they might have units like centimeters, meters, inches, feet, miles, yards, I don't know, whatever. Or they might not. Either one is fine. All right, so you need to be able to do some labeling. Oh, not only do they represent the sides, but it's a side opposite the matching angle. So we go A and we go across, then this side is little a. If we go B, we go across the opposite side, this little b, and we go across like this. That's little c. Same thing on this one, except going backwards. So if this is h, if I go across from little h, this must be angle h. This must be angle b. And this must be angle r. Now, trick question. Which of these sides is the hypotenuse? Yeah, notice I said trick question. What do you need before you have a hypotenuse? Yes, you need a 90-degree angle. So the trick here is there isn't one. No 90-degree angle, no hypotenuse. As I said, I think in the first video, you don't get to use that word anymore. Okay, unless you're doing that really long solving using Pythagorean's theorem that I showed you in the last video, you don't get to use it. Okay, now, here is the key for the sine law. You have to be able to find matching things. You need a matching pair of the length of the side and the opposite angle. Okay, so we need to know matchy-matchy. And it can be side-side angle, angle-side angle, angle-angle side, or you know what, just look for that matching pair. So if we go this side, there's a lovely matching pair. I've got an angle, so this is angle, side, side. Whoops, sorry, side, side, angle. Okay, so side, side, and then angle. basically it's the angle isn't between the two sides. All right, let's see what we got here. Well, what I really care about right now is I've got this lovely matching pair, and just because we need practice on this, it is a side, and an angle. But why can't I say, and yeah, I know you could do it the other way, but let's not. Okay, this one, I got an angle and a side and an angle. Oh, I guess I could have done this on this one. Angle, side, side. Anyway, this is an ASA. Now, this actually will work for sine law. And you're saying, but you just told me there needs to be a matching pair. But you guys are clever. Remember, if you have two angles in a triangle, you can calculate that. And then you'd have your delightful matching pair that you need. And there we go. And then this one is, there's a side and an angle. So side, angle. So it's always looking for that matching across, an angle and a side. If you have that, then for sure you can use the sine law, and it's a beautiful thing. All right, end of the video.